Okay, so we're going to divide complex numbers. We want to recognize that a complex number is written such that A is the real part and BI is the imaginary part. However, B is a real number and so is A. I is your imaginary number, and the formal definition of I is that I squared equals -1, which means that I equals the the square root of -1. So we have to keep that in mind. We also need to keep in mind that I squared equals -1, as I've written up here, and we always want to replace I to any exponent with its evaluated value, or its true representation. So I squared is equal to -1, and we're going to see that come into play several times. So I just wanted to recall that information. Okay, when we're dealing with division of complex numbers, we have to be able to create the conjugate of the denominator. So the conjugate of the denominator is actually, it looks very much like the denominator, except we simply change the sign of the imaginary part. Because we're going to multiply by that conjugate, it'll actually cause the I to go away. So we're going to distribute this binomial into this binomial. So we've multiplied the first term of the binomial, which is 4 times 4, and it gets us 16. So we did that multiplication. Then we're going to multiply the 4 times the 3i. So we're just distributing the 4 into both terms on the other binomial. So 4 times 3i gives us positive 12i. Okay, so now we're going to distribute the -3i. First, we're going to distribute it to the 4. So -3i times 4 is -12i. And then we're going to distribute the -3 to the -3i to the positive 3i. And we're going to get a -9i squared. Okay, so we can recognize that these two terms, they're like terms, and they cancel one another out. So we're left with 16, not plus, but minus 9i squared. But remember that I squared, if we recall over here, I squared equals -1. So we really have 16 minus 9 times -1, which gives us 16 plus 9, which ends up being 25. So that is why we use the conjugate, because it removes the I out of the problem and it leaves a real number in its place. Okay, so when we do that to the denominator, that's one thing, but we also have to do the same thing to the numerator. So let me back up just a minute. And up here, we have to recognize that whatever we do to the denominator, and what we did to the denominator was multiply it by the conjugate, so therefore we have to multiply the numerator by the same thing, because a number over itself, divided by itself, is just 1, and we can multiply anything by 1. Okay, so we already did the denominator, and we came up to 25. So now let's multiply the numerators, or the 3 plus 2i times 4 plus 3i, to find out what our new numerator is, because then we're going to be done with this problem. Okay, so we have the numerator 3 plus 2i times the conjugate of the denominator so that we can finish up this problem. So we're going to multiply the 3 times the 4. We're distributing the 3 into the second binomial. So 3 times the 4 gives us 12, and then 3 times the 3i gives us plus 9i. Okay, and now we're going to distribute the 2i. So 2i times 4 gives us a plus 8i, and then 2i times 3i gives us a plus 6i squared. Okay, so we need to simplify this a little bit. So 9i plus 8i is 17i. So we have 12 plus 17i. Now we recognize over here that I squared equals -1, so we're going to have a -6. Okay, so we still have some like terms because -6 and 12 are both constants, so we can combine those and just get 6. So our numerator ends up being 6 plus 17i. And we can write that back up into the numerator. So 6 plus 17i, and we have the solution to our problem now. And we've done that division. So I'm going to give you a problem for you to work and then resume the video so that you can see the answer. Alright, so here's the problem that I want you to work on, and then resume the video so that you can see how to solve it. Okay, so the first thing we're going to do is decide what the conjugate is. The only thing that we change is the sign of the imaginary part. So we're going to multiply both the numerator and the denominator by the conjugate of the denominator, which is simply -3 plus 2i. Okay, so now we just have to do this multiplication. So we have -3 minus 2i times -3 plus 2i. Okay, so -3 times -3 gives us 9. -2i times -3 gives us positive 6i. 2i times -3 gives us a minus 6i. And then -2i times a positive 2i gives us a -4i squared. Okay, so we have all of that. This cancels out because they add up to be 0. So we have 9 minus 4i squared. I squared is just -1, so we have 9 plus 4, which gives us 13 for our denominator. Okay, our numerator is going to be -2 plus 4i times -3 plus 2i, and that's going to just be distributed out. So -2 times -3 gives us positive 6. -2 times positive 2i gives us -4i. 4i times -3 gives us -12i, and then 4i times 2i gives us a positive 8i squared. Okay, so we're going to combine like terms, so we have 6 minus 16i, and then we know I squared is -1, so we have a minus 8. That -8 and the 6 can be combined, and so you end up with a -2 minus 16i for the numerator. So now when we write the answer, we end up with -2 minus 16i, all divided by 13. And that's the answer to that problem. Let me give you one more and for you to solve, and I think you probably have it. Okay, so here's the next problem for you to solve. Work through that, and when you resume the video, I'll just have the answer ready for you. Okay, so working this one very quickly, the conjugate is 4 plus 2i. We're going to multiply both the numerator and the denominator by it. When you multiply those out, you end up getting for the numerator 22 plus 26i, and the denominator is 20. Okay, now recognize that you can divide out a 2 in both the numerator as well as the denominator, which I did down here, because 2 times 11 plus 13i gives you this, and 2 times 10 gives you that. And so since 2 divided by 2 is just 1, we can divide the 2's out of there, and now we're left with this as our answer. Good luck on these problems.